Hello students, welcome to Yupp Master. This is 11th class IIT English Live. I am Radha Krishna, mathematics teacher. Today we are going to discuss arithmetico-geometric progression and also about arithmetic mean, geometric mean and harmonic mean. Alright, this is a part of sequences and series topic. This is 4th lecture. Alright, now let us discuss what is arithmetico-geometric progression. You observe the series A plus D into R, A plus 2D into R square, A plus 3D into R cube and so on. In this series, what can you notice? If you write the first term as A into 1, then the first factors are A plus D, A plus 2D, A plus 3D and so on. They are in AP, right? Now the second factors are 1, R, R square, R cube and so on. The second factors are in geometric progression. This kind of progression is called arithmetico-geometric progression. Simply you can call it as AGP. Alright. Now, what is the formula for sum of the n terms of this AGP? The formula is very long, complicated to remember. Sn is equal to A by 1 minus R plus dr into 1 minus R power n minus 1 by 1 minus R whole square minus A plus n minus 1 into D into R power n by 1 minus R. Let us have a quick look at the proof of this formula. The series is A plus D into R plus A plus 2D into R square plus A plus 3D into R cube and so on. You can easily tell the nth term. Nth term is A plus n minus 1 into D A plus n minus 1 into D into R power n minus 1. Alright. Denote this sum by Sn. And you remember a general point I have already explained in geometric progression. Whenever a series contains the terms of GP as factors like 1, R, R square, R cube and so on. If you write the first term as A into 1, then the second factors are in GP. First factors are in AP of course, but whatever be the first factors, if the second factors are in GP, we have to follow a method to find the sum of the series. What is that method? Multiply both sides by the common ratio and subtract. Common ratio of the GP is R, so multiplying both sides by R, we get R into Sn is equal to A into R, AR, but you should start writing the second row from second place. A into R is AR, right under the second term, plus this into R will be A plus D into R square, right under the third term. Alright, A plus D into R, R square, plus this into R will be A plus 2D into R cube. And so on. Now, under the last term, you will get the previous term into R. What is the previous term? A plus n minus 2 into D into R power n minus 2. If you multiply by R, it becomes A plus n minus 2 into D into R power n minus 1. But this into R, last term into R will come next to this. So, I will write it here plus A plus n minus 1 into D into R power n minus 1 into R will be R power n. Now, what will you do? Subtract from one another. subtracting Sn minus r, Sn is 1 minus r into Sn. Now a minus, there is nothing, so a minus 0, a plus this minus this will be what? Dr. Ar cancels, you will get dr plus this minus this will be dr square. This minus this is dr cube and so on. This minus this will be dr power n minus 1. Dr power n minus 1, but one more term is left in the second row. In the first row, next term should be taken as 0. 0 minus this last term will be minus of a plus n minus 1 into d into r power n. Alright. Now, if you observe, excluding first and last terms, the remaining sum is a GP. This part is a GP. Alright. So, we can apply the formula for sum of a GP. What is the formula for sum of a GP? A into 1 minus r power n by 1 minus r. So, I will calculate this. A plus first term as it is. This is a GP in which first term is dr, common ratio is r. And what is the total number of terms? Power of r varies from 1 to n minus 1. So, there are n minus 1 terms. Alright. So, the sum of this GP is dr into first a into first term into 1 minus common ratio for number of terms upon 1 minus r. Alright. Minus remaining term as it is a plus n minus 1 into d into r power n. Now, dividing both sides by 1 minus r, we get the required result. Sn is equal to a by 1 minus r plus dr into 1 minus r power n minus 1 upon 1 minus r whole square minus a plus n minus 1 into d into r power n upon 1 minus r. This is our formula given in the second point, but it is difficult to remember this kind of formula. So, I suggest you not to by heart this formula, but you remember the method. What is that method? Multiplying by the common ratio and subtracting. That will be easy. Alright. Now, if mod r is less than 1, then we can find the sum of this AGP till infinity. That is called infinite AGP. It is called infinite AGP. When mod r is less than 1, then only you can find. Now, let us derive this formula from the obtained formula. Here, if mod r is less than 1 and n tends to infinity, when number of terms is infinity, then we have to take n is approaching infinity. Then, first let us take the last term. When mod r is less than 1, any number less than 1, mod r is less than 1 means r lies between minus 1 and plus 1. Any number between minus 1 and plus 1 power infinity will be approaching 0. So, this part will be approaching 0. This is 0 when n tends to infinity. When n tends to infinity and mod r is less than 1. Alright. Similarly, here if n tends to infinity, n minus 1 also tends to infinity. So, this becomes r power infinity tends to 0. This part also tends to 0. Alright. Then what will be the sum of the series? When n tends to infinity, the sum of the infinite AGP is written as S infinity. A by 1 minus r remains as it is plus dr into 1 minus 0 by 1 minus r whole square is dr by 1 minus r whole square. The next term is 0 into anything is 0. So, this is 0. So, sum of the series up to infinity is given by a by 1 minus r plus dr by 1 minus r whole square. But what if mod r is greater than 1? If mod r is greater than 1, the series will be divergent. Divergent means the values of the terms will be increasing. So, final term will be approaching infinity. You cannot find the sum. The sum will be an infinite number, alright, because if n is approaching infinity and mod r is greater than 1, any number greater than 1 power infinity will be approaching infinity. So, you will not be able to find the sum, alright. And all of you remember this formula for infinite AGP. This is very, very important. Usually you won't require this formula in problems, you require this formula only, alright. So, all of you remember this formula for infinite AGP. Now, let us solve one example. Find the sum 1 plus 3 into 1 by 4 plus 5 into 1 by 16 plus 7 into 1 by 64 and so on. As if you observe, first term is 1 into 1, first factors are 1, 3, 5, 7 and so on. It is an AP. First term A is 1, common difference D is 2, alright. Now, if you observe the second factors 1, 1 by 4, 1 by 4 square, 1 by 4 cube and so on, they are in GP. The common ratio is R is equal to 1 by 4, alright. So, this is AGP. First factors are in AP, second factors are in GP. Now, we can apply the formula for sum of the series up to infinity. S infinity is equal to A by 1 minus R plus dr by 1 minus R whole square is equal to 1 by 1 minus 1 by 4 plus dr 2 into 1 by 4 by 1 minus 1 by 4 whole square. You know how to simplify it. If you simplify, you will get the answer 20 by 9. This is our answer, alright. It is a simple example for sum of infinite AGP. Now, we are going to discuss some more theory points. What is arithmetic mean? What is geometric mean? What is harmonic mean? First, let us discuss about arithmetic mean. If three numbers A, B, C are in AP, the middle number B is called arithmetic mean of A and C, alright. And we know that if A, B, C are in AP, B is equal to A plus C by 2. So, arithmetic mean of two numbers A and C is nothing but sum of the numbers by 2 or simply average, alright. If A, B, C, D, four numbers are in AP, then the two middle numbers are called arithmetic means between A and D. So, there are two arithmetic means between A and D. Like this, you can have any number of arithmetic means between two given numbers. Suppose A, A1, A2, A3 and so on, A n comma B are in AP. Then all these n numbers can be called as arithmetic means between A and D, A and B, alright. Next, the single arithmetic mean between two numbers A and B is A plus B by 2, same thing. Arithmetic mean of A and C is A plus C by 2, arithmetic mean of A and B is A plus B by 2, that is single arithmetic mean. In this way, we can have many arithmetic means between A and B. Now, we are going to discuss how to find a particular arithmetic mean among the n arithmetic means. If n arithmetic means are inserted between A and B, what does it mean? Suppose two numbers are given, you want to have some given number of arithmetic means, suppose say 10 arithmetic means. Then we have to find 10 numbers between A and B such that the series from A to B will be an arithmetic progression, alright. Now, so what we have to find? Single arithmetic mean between A and B is A plus B by 2. Now, we are going to derive the formula for finding a particular arithmetic mean between two numbers when n arithmetic means are inserted between A and B. If n arithmetic means are inserted between A and B, first we have to find the common difference of the arithmetic progression. Let us take the arithmetic means as A1, A2, A3 and so on, An. be the n AMs between A and B. What does it mean? A1, A2, A3 and so on, AN comma B are in AP. Now we have to find the common difference of this AP. What is the total number of terms? These are n arithmetic means n terms plus one term. So totally n plus 2 terms are there. So B is Tn plus 2. What is Tn plus 2? You know that Tn is A plus n minus 1 into D. First term is A only. Tn plus 2 will be A plus n plus 1 into D. Alright. N plus 2 minus 1, n plus 1 into D. So n plus 1 into D will be equal to B minus A. So we get D, common difference of the progression is B minus A by n plus 1. Okay. Now, suppose you want to find a particular arithmetic mean, say kth arithmetic mean you want. Kth arithmetic mean is equal to, first arithmetic mean is what? If these are in AP, first arithmetic mean A1 is A plus D, second A2 is A plus 2D, A3 is A plus 3D. So AK is A plus KD. Alright. Substitute D, already calculated now. So substitute D as B minus A by n plus 1, A plus K into B minus A by n plus 1, then you will get n plus 1 is LCM, you will get n plus 1 into A plus KB minus KA. You can write this in a proper form, you can easily remember. N minus K plus 1 into A plus KB by n plus 1. Taking A common from first and last terms, you will get this. So all of you should remember this formula as formula for kth arithmetic mean from left. Similarly, this is kth AM from left. Now, what is kth arithmetic mean from right? And kth arithmetic mean from left is AK. Alright. Now, kth arithmetic mean from right will be what? First arithmetic mean from right is AN, second arithmetic mean from right is AN minus 1, third is AN minus 2. So, kth arithmetic mean from right will be A n minus k plus 1. What is it? Again, you don't need to calculate like this. Simply, if you write the AP backwards from B to A in the decreasing order, what happens? This kth AM from right becomes kth AM from left, where B becomes first term, A becomes last term. So, simply by interchanging A and B in the previous result, you will get kth arithmetic mean from right. So, I will interchange A and B, n minus k plus 1 into B plus Ka by n plus 1. This is kth arithmetic mean from right. Alright. So, these results are given. Now, the sum of the n arithmetic means between A and B. See, here we have written n arithmetic means between A and B. I want the sum. What sum you want? A1 plus A2 plus A3 and so on AN. From A1 to AN, it is an AP. Even if you remove A and B, it is an AP. Sum of n terms of the AP is what? N by 2 into first term plus last term, A1 plus AN. Alright. But A1 is nothing but A plus D, an is nothing but b minus d. So if you write n by 2 into a1 is a plus d, an is b minus d. A plus d plus b minus d. So d cancels. So you will get the result n by 2 into a plus b. Alright. So sum of n arithmetic means between a and b is given by the result n by 2 into a plus b. Alright. Now let us discuss about geometric mean. If a, b, c are in GP, then the middle number b is called geometric mean of a and c. And you know that b square is equal to ac. When a, b, c are in GP, b square is equal to ac. So b is equal to plus or minus root ac. So geometric mean of two numbers a and c is nothing but plus or minus square root of the product. If a, b, c, d are in GP, then b and c both are called two geometric means between a and d. Similarly, between a and b you can have n geometric means like this. If the series from a to b, a, g1, g2, g3 and so on gn comma b are in GP, then these numbers g1 to gn are called n geometric means between a and b. Okay. Now single geometric mean between a and b is plus or minus root ab, same thing. Now we are going to discuss how to find a particular geometric mean in this GP. First we have to calculate the common ratio. A, G1, G2, G3 and so on Gn comma B are in GP. Alright. Then total number of terms is n plus 2. So B is equal to Tn plus 2. You know the formula for nth term of a GP, a r power n minus 1. If the common ratio is r, it will be a r power n plus 2 minus 1 will be n plus 1. Then we will get r power n plus 1 is equal to b by a. Alright. Then r is equal to b by a power 1 by n plus 1. Alright. Okay, this is common ratio. Now I want a particular geometric mean, say kth geometric mean you want. Kth geometric mean from left. It is gk. Then G1 is AR, G2 is AR square, G3 is AR cube and so on. So gk will be AR power k. Substitute this r. You will get a into b by a whole power k by n plus 1. Alright. If you simplify this, you will get a formula a power n minus k plus 1 into b power k whole power 1 by n plus 1. This is the formula for finding kth geometric mean from left. Now, if you want kth geometric mean from right, what will you do? Simply interchange a and b. Kth geometric mean from right. How do you write it? First geometric mean from right is Gn, second is Gn minus 1, third is Gn minus 2 and so on. So, kth geometric mean from right will be Gn minus k plus 1. Just by interchanging a and b you will get it. B power n minus k plus 1 plus a power k by whole power 1 by n plus 1. Alright. Next, in case of arithmetic means, if n arithmetic means are inserted between a and b, we have written a result for sum of all the arithmetic means. But in GP, in case of GMs, we write a formula for product of the n arithmetic means. Product of the n GMs between A and B is, that is nothing but G1, G2, G3 and so on, Gn you want. In GP, we have discussed one property of a geometric progression. Product of the terms equidistant from left and right will be same. That means first term into last term will be same as second term from left into second term from right. So, AB is equal to G1 Gn is equal to G2 Gn minus 1 and so on. Okay. So, G1 into Gn is AB, G2 into Gn minus 1 is AB, G3 into Gn minus 2 is AB. So, if you pair like this, terms equidistant from left and right are paired, then total number of factors is n. So, how many pairs you will get? N by 2 pairs. Okay. So, you will get this product as each pair has value AB now. So, AB power n by 2, that is the product of n geometric means between A and B. Alright. Now, the same points, common ratio is R is equal to B by A whole power 1 by n plus 1 we have derived, and kth Gm from left, kth Gm from right, and product of the n geometric means between A and B is AB power n by 2. Alright. Now, let us discuss about harmonic mean. If A, B, C are in HP, then the middle number B is called harmonic mean of A and C, or simply you can call it as HM. If A, B, C, D are in HP, then B and C are called two harmonic means between A and D. Similarly, if n harmonic means are inserted between A and B, denote them by H1, H2, H3 and so on Hn, then A, H1, H2, H3 and so on Hn, B will be in AP. Then the numbers H1, H2, H3 and so on Hn are called n harmonic means between A and B. Next, single harmonic mean between A and B. Here, if A, B, C are in HP, you have a formula discussed in the previous class. B is equal to 2AC by A plus C, if A, B, C are in HP. So, the harmonic mean of A and C is B is equal to 2AC by A plus C. So, what is the harmonic mean of A and B? 2AB by A plus B. Alright. Next, if n harmonic means H1, H2, H3 and so on Hn are inserted between A and B, then how to find a particular harmonic mean from left? You need not derive again. What we will do is, between A and B, you have written n harmonic means. So, A, H1, H2, H3 and so on Hn, B are in HP. Alright. You want Hk, kth harmonic mean from left. If you take reciprocals of the terms of HP, 1 by A, 1 by H1, 1 by H2, 1 by H3 and so on, 1 by Hn, 1 by B are in AP. Is it not? Reciprocals of the terms of harmonic progression will be in arithmetic progression. Now, these numbers 1 by H1, 1 by H2 and so on 1 by Hn are called arithmetic means between 1 by A and 1 by B. Already we have derived formula for kth arithmetic mean. Here, what is the kth arithmetic mean from left? It will be 1 by Hk. So, for getting this, we can use the previous formula which we have derived. Kth arithmetic mean is n minus k plus 1 into first term 1 by A. In the formula of that arithmetic mean, we have to replace A by 1 by A, because first term is 1 by A, last term is 1 by B, into 1 by A plus k into 1 by B by n plus 1. If you simplify and take reciprocal, you will get Hk is equal to n plus 1 into AB by n minus k plus 1 into B plus Ka. This is kth harmonic mean from left. Similarly, kth harmonic mean from right. Kth harmonic mean from right will be h n minus k plus 1 is equal to, how do you get? Just interchange a and b. If a and b are interchanged, numerator remains as it is, denominator becomes n minus k plus 1 into a plus kb. Alright, n plus 1 into ab, this remains as it is, by n minus k plus 1 into a plus kb. So, these two are the results given here. Alright, you have to remember all these things. Now, let us proceed to the next point. There are some important relations between AM, GM, HM. Quickly let us discuss the relations. If A and B are positive, then A plus B by 2 is arithmetic mean, that is greater than or equal to geometric mean root AB, greater than or equal to harmonic mean 2AB by A plus B. Okay, AM is greater than or equal to GM, greater than or equal to HM when A and B are positive. And this equality occurs when the two numbers are equal. Already we have been discussing this in previous chapters. Okay, whenever AM is equal to GM or GM is equal to HM or AM is equal to HM, the two numbers must be equal. When A and B are negative, then arithmetic mean is A plus B by 2, but geometric mean should be taken as minus root AB, harmonic mean is 2AB by A plus B. Now the relation is reverse. AM is less than or equal to GM, less than or equal to HM. Alright, all of you carefully remember this. Next point, if you take n numbers, A1, A2, A3 and so on, An or n positive numbers, then their arithmetic mean will be greater than or equal to geometry mean, greater than or equal to harmonic mean. When there are n numbers, all numbers should be positive, otherwise we will not discuss AM, GM, HM inequality. What is arithmetic mean of these numbers? Simply sum of the numbers by n. You can write it as sigma ai by n, by n is missing, okay. Sigma ai by n, this n is not there. Sigma ai by n is greater than or equal to the geometric mean of n numbers is their product power 1 by n, nth root of their product. Geometric mean of two numbers is square root of the product. Geometric mean of three numbers A, B, C is cube root of the product. Geometric mean of n numbers is nth root of the product, alright, where all numbers are positive. And geometric mean of harmonic mean of two numbers is 2AB by A plus B. We can write it as 2 by 1 by A plus 1 by B. Similarly, geometric harmonic mean of n numbers A1, A2, A3 and so on, An will be n by 1 by A1 plus 1 by A2 plus 1 by A3 and so on 1 by An. So, simply we can write this result as sigma ai by n is greater than or equal to pi of ai, that is product, whole power 1 by n, greater than or equal to n by sigma 1 by ai. This is harmonic mean, this is geometric mean, this is arithmetic mean. Am greater than or equal to GM, Am greater than or equal to GM, greater than or equal to HM. Where the equality occurs when A1 is equal to A2 is equal to A3 and so on. So, whenever this is equal to this, Am is equal to GM, all numbers must be equal. Whenever this is equal to this, all numbers must be equal. Okay. Now, next point, if A, G, H are respectively the AM, GM, HM of two numbers, what is AM? A is equal to A plus B by 2 and geometric mean is plus or minus root AB and harmonic mean is 2AB by A plus B. And this can be written as 2 into AB can be written as G square and A plus B can be written as 2A. So, H is equal to G square by A means G square is equal to AH. This is the relation between arithmetic mean, geometric mean and harmonic mean of two positive numbers. two numbers, that is all. Okay. Now, AGH will be in geometric progression. Arithmetic mean, geometric mean and harmonic mean of two numbers are in geometric progression. Alright. Next, if A1, A2, A3 and so on An are n arithmetic means between A and B, and G1, G2, G3 and so on Gn are n geometric means between A and B. Similarly, H1, H2, H3 and so on Hn are n harmonic means between A and B. That means equal number of AMs, GMs, HMs are inserted between two numbers A and B. Then one point, very important point is, if you take kth AM from left, it will be AK, kth HM from right will be Hn minus k plus 1. Already we have derived the formula for AK and Hn minus k plus 1. AK is n minus k plus 1 into A plus KB by n plus 1. And Hn minus k plus 1, kth harmonic mean from right will be n plus 1 into AB by n minus k plus 1 into A plus KB. You can observe that their product is AB. Product of kth AM from left and kth HM from right will be equal to AB. Similarly, product of kth AM from right, this is kth AM from right into kth HM from left will also be equal to AB. Alright, very important, very useful formula this is. Now one more thing is G1, G2, G3 and so on Gn whole square. Product of all geometric means is this square of that will be equal to product of all AMs and all HMs. You can easily prove it. Already we have discussed that product of all GMs is AB power n by 2. We have derived this. Now, if you take product of all AMs into product of all HMs, then according to this result, first arithmetic mean into last harmonic mean will be AB. So, this into this is AB. Similarly, A2 into Hn minus 1 will be AB. A3 into Hn minus 3 is AB. In this way, if you pair them, what happens? How many ABs will come? There are n AMs and n HMs. So, every one AM is paired with corresponding HM. So, you will get n pairs exactly. So, every pair is AB. So, this product will be AB power n, which is equal to this whole square, is it not? AB power n by 2 whole square is AB power n. Hence, we get the last point. Alright. Now, let us solve problems on infinite AGP, AM, GM, HM quickly. First question, if mod x is less than 1, evaluate the sum 1 plus 3x plus 6x square plus 10x cube plus 15x power 4 and so on till infinity. Is this AGP? No, because the first factors are 1, 3, 6, 10, 15, that is not AP. Difference between 1 and 3 is 2, difference between 3 and 6 is 3, difference between 6 and 10 is 4, difference is not remaining same. But second factors are in GP. If you take first term as 1 into 1, 1x, x square and so on, that is GP. So, when the second factors are in GP, whatever be the first factors, we follow the same method. What is that method I told? Multiply both sides by the common ratio and subtract. Okay. First, denote the sum by S. S is equal to 1 plus 3x plus 6x square plus 10x cube plus 15x power 4 and so on till infinity. Alright. Multiply both sides by the common ratio. Common ratio of the GP part is x. Multiplying by x, you should start writing the series in the second row from second place. 1 into x is here, plus 3x into x is 3x square. Next this into x is 6x cube, plus this into x is 10x power 4 and so on till infinity. Then you subtract them. This minus this is 1 minus x into x, s. This minus 1 minus 0, 1. This minus this 2x. This minus this 3x square. Next this minus this 4x cube and so on. What is this now? It is AGP. Now you can apply AGP formula. Suppose you don't know, you don't remember the formula of sum of infinite AGP. No issue. You can still find it. How? Repeat the same method. Multiply by the common ratio and subtract. Multiplying by common ratio x, x into 1 minus x into s is equal to this into x, write it here, this into x 2x square, this into x 3x square, 3x cube, sorry, and so on. Subtract. This minus this will be 1 minus x into s will be common. Here 1 will be remaining, here x, 1 minus x. So another 1 minus x is coming as a factor. So this becomes 1 minus x whole square into s. What are you getting in the RHS? 1 minus 0, 1. This minus this x square plus x cube and so on. You got infinite GP, whose sum is a simple formula a by 1 minus r. Alright. See, whenever the second factors are in GP, whatever be the first factors, you continue this procedure. At some stage, you must get infinite GP. That is for sure. If you are not getting infinite GP, you cannot find the sum. The problem is wrong. Suppose you don't remember the formula for sum of infinite GP also. No issue. Still you can find. Repeat the method. Multiply both sides by x. X into 1 minus x whole square is equal to, into s is equal to 1 into x into x square into x cube and so on. Then subtract. Subtracting this minus this will be 1 minus x whole cube into s, and this minus this is 1. So s is equal to 1 by 1 minus x whole cube. We got the answer. Alright, we have not used any formula. Alright, remember this technique. Next question. The AM of two numbers exceeds their GM by 3 by 2. The GM exceeds HM by 6 by 5. Find the numbers. Let A and B be the numbers. Okay, and let A be the arithmetic mean. Arithmetic mean is A plus B by 2. G be the geometric mean. Geometric mean is plus or minus root AB. Let H be the harmonic mean. H is equal to 2AB by A plus B. Alright. What is given? Arithmetic mean exceeds the geometric mean by 3 by 2. So A is equal to G plus 3 by 2. And harmonic GM exceeds harmonic mean by 6 by 5. So G is equal to H plus 6 by 5. This is the given information. Between two numbers, the arithmetic mean, geometric mean and harmonic mean of two numbers have a relation. What is that relation? We have G square is equal to AH. Is it not? So let us substitute A as G plus 3 by 2. G square is equal to G plus 3 by 2 into what is H? H is G minus 6 by 5. Multiplying RHS, you will get LHS G square is equal to RHS is G square minus 6G by 5 plus 3G by 2 minus how much? 9 by 5. Alright. Now G square cancels. If you take it this side and calculate 3 by, we will get 6 by 5 minus 3 by 2 into G is equal to minus 9 by 5. What is this? 12 minus 15 minus 3 by 10, is it not? No, 12 minus 15 minus 3 minus 3G by 10 is equal to minus 9 by 5. So, let us cancel. 5 2s are, so 3 also, minus 3 also cancels. So, you will get G is equal to 6. G is equal to 6 means, what is A? We got G is equal to, that is 6, and A is equal to, A is equal to G plus 3 by 2. So, 6 plus 3 by 2, 15 by 2. And A is nothing but A plus B by 2 is how much? 15 by 2. So, we get A plus B is equal to 15, and G square is equal to AB. AB is 36. When you have A plus B and AB, you can calculate A and B by finding A minus B whole square. A minus B whole square is equal to A plus B whole square minus 4AB. 15 square 225 minus 4AB is 4 into 36 144. Then you will be getting 81. Then A minus B is equal to plus or minus 9. From A minus B and A plus B, calculate A and B. You will get one number as 2, the other number is 12. Alright. No, I think 3 and 6 I think. 3 plus 6 by 2, 15 by 2 is matching, and root over 3 into 6 is 3 and 6. You may get 12 and 3 also. 3 and 12 or 12 and 3, both are correct. Alright. Now let us proceed to the next question. This is based on the property that we have discussed today. If 2, A1, A2, A3 and so on, A20, 3 are in AP. 2, A1, A2, A3 and so on, A20, 3 are in AP. And 6, H1, H2, H3 and so on, H20, 9 are in HP. But observe that 6 is 3 times of 2, 9 is 3 times of 3. So, you divide these terms of HP by 3. Then first number becomes 2, second number becomes H1 by 3, third number H2 by 3, H3 by 3 and so on, H20 by 3, 9 by 3, 3 are in HP. That means between 2 and 3 equal number of arithmetic means and harmonic means are there. When equal number of AMs and HMs are written between two given numbers, we have a formula. What is that formula? Product of kth arithmetic mean from left and kth harmonic mean from right will be equal to product of the extremities, 2 into 3. Observe, A7 is 7th AM from left. A7 into which harmonic mean will be product of 2 and 3? From right side, from 20 if you count 7th, it will be H14. So, 7th from right will be H14 by 3. This product should be equal to product of the extremities 2 into 3, that is 6. Therefore, A7 into H14 will be equal to 3 into 6, 18. This is 18. Similarly, this is H7 is 7th harmonic mean. Sorry, if you take 7th harmonic mean from left, it will be H7 by 3. From left, 7th harmonic mean into 7th harmonic mean from right. 7th arithmetic mean from right will be A14. So, this into A14 will be equal to again 2 into 3, 6. Therefore, A14 into H7 will be equal to again 18. So, this and this are equal, each value is 18. So, 18 plus 18, answer is 36. Alright. Next question. If 3, A1, A2, A3 and so on, A15, 5 are in AP, 3, H1, H2, H3 and so on, H15, 5 are in HP, find A6 plus 15 by H6. Here you want A6 plus 15 by H6. Let us try that property. If you take H6, it is 6th HM from left into 6th AM from right. What is it? A15, 14, 13, 12, 11, it will be 6th AM from right is A10. Product of 6th HM from left and 6th AM from right will be equal to 3 into 5, 15. Why? Because between 3 and 5, equal number of arithmetic means and harmonic means are inserted. 15 AMs and 15 HMs are inserted between 3 and 5. So, then we get this formula from our formula. Then 15 by H6 will be equal to what? A10. 15 by H6 is A10. So, this is nothing but A10. Then the asked value is A6 plus A10. Again, how to find? We have discussed one property of an AP. The sum of the terms equidistant from left and right will be same. That means 3 plus 5 will be equal to A1 plus A15 will be equal to A2 plus A14 and so on. In this way, you will get A6 plus A10. A6 is 7th term from left, A10 is 7th term from right. This sum will be equal to 3 plus 5. So, answer is 8. Alright. Next question. Just I will explain the method and you can solve it. Here between A and B, A1 and A2 are 2 AMs. A1, A2, B are in AP. A, G1, G2, G3, A, G1, G2, B are in GP. So, G1 and G2 are 2 geometric means between A and B, and H1, H2 are 2 harmonic means between A and B. A1, A2 are 2 arithmetic means between A and B. Now, we have to prove this. First, let us use the property of arithmetic progression. If this is AP, then first term plus last term, A plus B will be equal to A1 plus A2. So, A1 plus A2 will be equal to A plus B. Alright. What is the property of GP? product of the terms equidistant from left and right will be same. So, A into B will be equal to G1 into G2. So, G1 G2 is equal to AB. What is the property of harmonic progression? Sum of the reciprocals equidistant from left and right will be same. So, 1 by H1 plus 1 by H2 will be equal to 1 by A plus 1 by B. Alright. Then this can be written as H1 plus H2 by H1 H2 is equal to RHS is A plus B by AB. Alright. A plus B is A1 plus A2, AB is G1 G2. So, this is equal to A1 plus A2 by G1 G2. Cross multiplying, we get A1 plus A2 by H1 plus H2 is equal to G1 G2 by H1 plus H1 H2. So, we have proved the first part, this part is proved. Now, to prove the next part, let us take any one of them. I will take this. Already we have G1 G2, G1 G2 is AB. You need to calculate H1 H2. You cannot get H1 H2 directly in one step. We have to calculate H1 and H2 separately. H1, it is first harmonic mean from left. I have given you a formula. If we apply the formula, n number of the harmonic means is 2. So, n is 2, k is 1. So, the formula is 2 minus 1 plus 1, n minus k plus, sorry. This is H1 is equal to, what is the formula? N plus 1 into AB by n minus k plus 1 into B plus Ka. This is our formula for kth harmonic mean from left. N is 2. So, 2 plus 1 into AB by 2 minus 1 plus 1 into B plus K is 1 now. So, A. So, we are getting 3AB by what will get A plus 2B, H1. Similarly, H2 is first harmonic mean from right. So, we can get H2 by just interchanging A and B here. So, H2 is equal to 3AB by denominator becomes B plus 2A or 2A plus B. Now, you want G1 G2 by H1 H2. Already you have G1 G2 as AB. G1 G2 is AB. Already we have calculated H1 and H2. Substitute H1 3AB by A plus 2B into 3AB by 2A plus B. Then simplifying it, you will get the required answer, A plus 2B into 2A plus B by 9AB. Hence, it is completely proved. Okay. So, these are the problems on AM, GM, HM. So, tomorrow after solving 2 or 3 problems more in AM, GM, HM, we are going to discuss summations in sigma form. Alright. So, see you tomorrow. Thank you very much for watching.